Okay, so this segment is going to be on the empirical rule. I figure that's a good thing to practice. Okay, so I'll read this with you. The following data, I'm going to do number 24. The following data represent the length of eruption for a random sample of eruptions at Old Faithful Geyser in California. Okay, so here's all our data. Determine the sample standard deviation length of the eruption. And then it says, on the basis of the histogram, comment on the appropriateness of using the empirical rule to make any general statements about the length of eruptions. And then lastly, we use the empirical rule to determine the percentage of eruptions that last between 92 and 116 seconds. Okay, well, now we went over a formula in class for how to compute sample standard deviation. And I'm certainly not going to, especially with a data set this large, I'm not going to make you do that on a test. So option 1 is you type all of this data into your graphing calculators. What I'm going to do, though, is use the StatCrunch feature right here, SC, and I'm going to pull that data up, which is like Excel. So let me hit pause as I do that. So you see, we have that built-in tool with our textbook, StatCrunch, which basically banks all of the data for us into something that looks like Excel. So here we have all the length of eruptions. So rather than me having to get the standard deviation by hand, I'm going to use the lovely stat feature up here, and let me just highlight that, stat, okay? So I'm going to go stat, summary statistics, columns, and again, this is if you're using this feature, you can certainly use your calculator. I just highlight length of eruption and it knows what to do, and hit next. And here I get to highlight various features that I want and hit calculate. Okay, so I will make that larger so you can see it. Okay, so I'm going to steal the standard deviation in essence from Excel, or from this very program that's like Excel. Okay. So I'm going to steal standard deviation. Then that is your sample standard deviation, 6.25. Like I said, you might want to verify that on your graphing calculator. Okay, and while we're at it, we should probably retrieve the mean as well. So X bar, sample mean. I'm just going to round to the nearest whole number, 104. And this, if I round to the nearest whole number, 6. Okay, and that. Now let me go back to the problem. Okay, so the original problem says determine the sample standard deviation and round to the nearest whole number. So I'll just record that here. So 6. Then it says on the basis of the histogram, comment on the appropriateness to use the, whether we can use the empirical rule or not. So let's make a histogram. And like I said, you guys know how to do that on your graphing calculators, so go for that. I'm just going to use the built-in feature of StatCrunch. Let's hit pause. Okay, so here I am in StatCrunch. I'm going to go to graphics. I'm going to go to histogram. Just highlight my column of interest, which is here, length of eruption. Hit next and hit create graph. And I see, okay, let me shrink this so you could see it. So I could see, okay, the data is fairly, oops, let me highlight that. Data is fairly normally distributed. And so we say, all right, it's fairly bell-shaped. It's not like it has severe left skew or severe right skew. So we'll use the empirical rule. Okay, let me hit pause and we'll finish the rest of that question off. Okay, now the final frontier would be to use the empirical rule to determine the percent of eruptions that last between 92 and 116 seconds. It says, hint, X bar is 104, the sample mean is 104. Well, we knew that because we retrieved it from the software. All right, let's draw this out. I'm going to bring up the whiteboard. Okay. So what we'll do is we'll draw a curve centered at 104. So draw a curve centered at 104. And we want to know 92 to 116. What percent of eruptions last between 92 and 116 seconds. Well, we happen to know that the standard deviation is 6. So you really want to think about, and I'm going to do this in another color, you really want to think about how many standard deviations away from the mean are you? Are you plus 2 sigma, plus 3 sigma, right? So 104 plus 6 would bring us, to 10, and then plus another 6 would bring us to 116. So we're plus 2 sigma, 2 standard deviations above the mean. Here we're minus 2 sigma, 2 standard deviations below the mean. So, what does the empirical rule say? Well, the empirical rule is the 68, 95, 99, 7 law. What it basically says is that 95% of the observations will lie between I'm going to write under here, plus or minus 2 sigma. The 68% of the observations will lie between plus or minus 1 sigma. And the 99.7 will lie within plus or minus 3 sigma of the mean. So the final answer to this is that 95%, according to the empirical rule, because that's plus or minus 2 sigma. So 95% of all the eruptions lie within those bounds. Lie within what bounds? 92 and 116. Okay? So again, always sketch it out and think to yourself, okay, plus or minus 2 sigma, okay, that's 95% of the observations, according to the empirical rule. Okay, hope that helps.